Relative velocity numerical number 4. Numerical number 4, relative velocity. To a driver going east in a car with a velocity of 40 km per hour, a bus appears to move towards north with a velocity of 40 root 3 km per hour. What is the actual velocity and direction of motion of the bus? According to this numerical, given velocity of the car, that is Vc is equal 40 kilometer per hour due east. Vc is equal 40 kilometer per hour due east. Apparent velocity or relative velocity of the bus with respect to the car. That means Vbc is equal to 40 root 3 kilometer per hour due north. Relative velocity of the bus with respect to the car, that is Vbc equal to 40 root 3 kilometer per hour due north. And we have to find actual velocity of the bus, that is Vb, V subscript small b equal question mark. Vb equal question mark, that means we have to find the actual velocity of the bus. Velocity of the car is given. Relative velocity of the bus with respect to car is also given, which is 40 root 3 km per hour due north. In the diagram, a car is moving with a velocity vector Vc towards east. A car is moving with a velocity Vc due east, and the bus will appear to move due north. The bus will appear to move due north with respect to the car. That means relative velocity of the car, relative velocity of the bus with respect to car is vector Vbc. The relative velocity of the bus, with respect to the car, relative velocity of the bus with respect to the car is given by vector Vbc is equal vector Vb minus vector Vc, vector Vb minus vector Vc. Therefore, vector Vbc equal vector Vb plus under bracket minus vector Vc. That means to find vector Vbc, we have to subtract vector Vc from vector Vb. That means we have to subtract velocity of the car from the velocity of the bus, Now we can draw west direction. This is west direction along which minus vector Vc is denoted. Hence, we should consider that the bus should be actually moving along a direction at an angle phi east of north, such that if we add vector Vb east of north and minus vector Vc due west, we get the resultant of vector Vb and minus vector Vc as vector Vbc due north. Vector Vbc is the relative velocity of the bus with respect to car due north, such that bus is actually moving east of north at an angle phi, and we can add vector Vb with minus vector Vc, and we get the resultant vector, that is vector Vbc due north. Hence the bus moves along a direction. Hence the bus moves along a direction at an angle phi east of north. The bus is actually moving in a direction at an angle phi east of north. In the diagram, vector Vb is denoted in a direction at an angle phi east of north. The bus moves along a direction at an angle phi east of north with the velocity with a velocity vector Vb, so that the bus will appear to move due north with the relative velocity vector Vbc. Therefore, vector Vbc is equal to vector VB plus under bracket minus vector VC, writing the expression of vector VBC as vector VB plus vector minus vector VC. Therefore, mod vector VBC is equal to root over VB square plus VC square minus 2VB VC cos phi. 2VB VC cos theta, not phi, cos theta, where theta is the angle between vector VB and vector VC. The car is moving with the velocity vector VC and the bus is moving with the velocity vector VB, east of north or north of east. Here we have shown the direction of motion of the car and the bus. Car and bus are moving with the velocities vector VC and vector VB due east and east of north. Therefore, or comma VBC is equal to root over VB square plus VC square minus 2VB VC cos theta. VBC is equal to root over VB square plus VC square minus 2VB VC cos theta, which is equation 1. Again, vector VBC is at an angle phi with the direction of vector VB. That's why tan phi will be equal to, now phi is measured with respect to vector VB. That's why VB is the first vector minus VC is the second vector. Vector VBC is at an angle phi with the direction of vector VB and acts at an angle of phi prime equal 90 degree with the direction of minus vector VC. Acts at an angle of phi dash is equal 90 degree with the direction of minus vector VC. Therefore, as phi dash is measured with respect to minus vector VC is the first vector and vector VB is the second vector. This is the angle phi dash which is equal to 90 degree and we can denote the angle theta which is the angle between vector VB and vector VC. But phi dash is the angle between vector VBC and minus vector VC. Tan phi dash, as phi dash is measured with respect to minus vector VC, that's why minus vector VC is the first vector, vector VB is the second vector. That's why tan phi dash is equal to mod vector VB sin 180 degree minus theta divided by mod minus vector VC. Now the angle between vector VB and minus vector VC is 180 degree minus theta divided by mod minus vector VC plus mod vector VB cos 180 degree minus theta. Or comma tan phi dash or tan 90 degree is equal to VB sin theta divided by, we know that mod minus vector VC is only VC. We are considering the magnitude only, minus vector VB minus VB cos theta. Or comma infinity equal VB sin theta divided by VC minus VB cos theta. Or comma 1 by infinity is equal to VB sin theta, VC minus VB cos theta divided by VB sin theta. Or comma 0 is equal to VC minus VB cos theta divided by VB sin theta. Or comma VC minus VB cos theta is equal to 0. Therefore, VB cos theta is equal to VC. VB cos theta is equal VC. VB cos theta is equal VC, which is equation 3. Using the equation 2 in equation 1, we get VBC as equal root over VB square plus VC square minus 2 VB VC cos theta. In place of VB cos theta we can write VC. That's why we get root over VB square plus VC square minus 2 VC under bracket VB cos theta. Root over VB square plus VC square minus 2 VC square equal root over VB square minus VC square. We get VBC as equal root over VB square minus VC square, or comma VB is equal root over VBC square plus VC square. VB is equal to root over VBC square plus VC square, or comma VB is equal to, putting the values, 40 root 3 whole square plus 40 square. VB will be equal to 40 is taken outside, under bracket root we have 3 plus 1. Therefore, VB is equal to 80 kilometer per hour. VB is equal to 80 kilometer per hour, which is the actual velocity of the bus. VB is equal to 80 kilometer per hour. This is the actual velocity of the bus. Now, to find phi, we have to consider equation 2. From equation 2, VB cos theta is equal to VC. VB cos theta is equal to VC, or comma cos theta is equal to VC by VB, or comma cos theta is equal to 40 by 80, cos theta is equal to 1 by 2, therefore theta is equal to cos inverse half, therefore theta is equal to 60 degree, that means pi by 3 radian. Theta is equal to 60 degree. Theta is the angle between the actual velocity of the bus VB and actual velocity of the car. Theta is equal to, theta plus phi is equal to 90 degree, and phi is 90 degree minus theta. So phi is equal to 90 degree minus theta is equal to 90 degree minus 60 degree. So finally we get phi as 30 degree. Phi is the angle between vector VB and vector VBC. Phi is equal to 30 degree. That is the angle of direction of VB with respect to VBC. So what we can conclude, that the bus is actually moving. The bus is actually moving with a velocity of 80 kilometer per hour, with a velocity of VB equal 80 kilometer per hour at an angle of phi equal 30 degree east of north, at an angle of phi equal 30 degree east of north. Finally, we can say that the bus is actually moving with a velocity of VB equal 80 km per hour at an angle of phi equal 30 degree east of north, at an angle of 30 degree east of north. Vector VB, in the diagram vector VB is equal to 80 km per hour at an angle of 30 degree east of north. That is the final answer. The bus is actually moving with a velocity 80 km per hour at an angle of 30 degree east of north.